All right, we want to look at identifying forces on an object. We're just going to look at two cases and identify the forces on an object. We'll start with an example of a box sitting on a surface. And the important thing to do when identifying forces is we decide which object is important. Then all we care about, once we've picked our object, so let's say our object is the box, we look at everything interacting with the box, every force that interacts with the box. We don't care about what our object does to anything else, we just care about what's happening to our object. In this case, when we look at our box, we say, well, the object has some weight. We draw our weight vector straight down. The other thing that acts on our object is our object sitting on a surface, so we have a normal force. And we look, there's nothing on the left side, nothing on the right side, so these would be the two forces that we'd identify. We have the normal force pushing up from the surface, and we have the weight of the object, from the gravitational force. So in this case, those would be the two forces. Now, if we drew our object on a slanted, well, we'd say, okay, we're still interested in the box. I know I didn't draw my box very well, so let me try one more time. So if we have an object on an inclined surface, we look and say, well, what's happening? Well, we know we have some type of normal force again. It acts perpendicular. So that's our normal force. And we have gravity working straight down. So we've identified the two forces. We don't see anything on either side of the box again. We may have to worry about, depending on the case here, we could potentially have to worry about the force of friction, be it static or kinetic. If we had friction in our surface, we would then have to incorporate that, but they would let us know if we had to include friction. So this is another possibility. We could have something like that. Now let's take a third look, and let's just say we have a box, and it's sitting in the air. In this case, we look around, and the only thing that we would put on the box is its weight, because the ground, let's say, is down here. So when we have something up in the air, the only force that acts on it is the weight. None of the other forces we have are acting on the box. So in that case, we draw just our weight, and we're done, because there's no support force, there's no thing. There could be, the drag force might be up, but this would be only if they told us to include. And normally most books will tell you to neglect air resistance. For those problems become difficult to solve. We just wanted to look at the idea of, hey, we have these different systems, and how do we know what forces to put on? Well, what we do is we look at our object, we look at everything in contact with our object, and then we label forces accordingly. So let's do one more example that looks a little bit different. So now we'll take a box, and we'll put somebody over here, and this person is pushing on the box, and then we have a rope, and this person is pulling on the box. So now we want to identify the different forces on the box. We have a force of a push acting here. We have the object's weight on this side. We have the normal force acting up. And then we have the force of tension on this side acting in that direction. So we've now labeled the forces on our object, on the different ones. And then we may or may not, we don't know, depending on the problem, friction could be included, but we'd have to know which direction the object would be moving, if it's moving at all, and then we would put in our friction in a direction to oppose motion. So here's just another example of, hey, we have a box. We look at what's going on. This person's pushing, so we put a vector that way. We know we have the weight acting down, because weight always acts down on everything any object we have will include its weight. We have the tension in this rope pulling up at that angle, coming off this side. And then we have the normal force up because it's coming off this surface. So we could even have drawn the normal down here, but since it's an upward force, I just put it on top of the box. But here's just another example of, hey, let's look at what's interacting with our box, and we label the different forces. And then we're unsure about friction because we don't know if it was frictionless or not. And then if it did have friction, we would just put it in the direction opposite of it was moving. So if we knew that the overall direction of motion was to the right, then we would have put our friction force in, kinetic or static, the other way. So this is just some examples of labeling forces onto objects.